Everyone, welcome back to my channel. I hope everyone is doing great. Let's solve second problem of biweekly context 175. Minimum k to reduce array within limit. Okay, you are given a positive integer array nums. For a given integer k, define non-positive nums comma k as the minimum number of operations needed to make every element of nums non-positive. Okay, in one operation you can choose an index I and reduce it to nums of I by k. Okay, so return an integer denoting the minimum value of k such that non-positive nums comma k is less than or equal to k square. Okay, so let's choose k equal to 1 first. Okay, if I choose k equal to 1, that means I have to subtract it 3 times, right? 3 minus 1 minus 1 minus 1, so then it will become 0. So in order to convert this into a non-negative non-positive number, it will take 3 operations. Similarly, for this it will take 7 operations, for this 5 operations. So total number of operations, if I choose k equal to 1, would be 3 plus 7 plus 5, which is 15. So total number of operations is 15, right? Is it less than or equal to k square where k is 1? No, it's not, right? So let me just pull it here. So the possible k values, let's have chosen k equal to 1. So total number of operations we got is basically 15, right? So they have mentioned that the number of operations should be less than or equal to k square. Is it true? No, it's not true, right? It's false. 15 is not less than or equal to 1. Okay, let's choose k equal to 2. Okay, so the total number of operations will be 3 divided by 2 seal of this plus seal of 7 divided by 5, 7 divided by 2 plus seal of 5 divided by 2. Okay, so this would be, it will take 2 operations to make it non-zero, which will be 2. This will take 4 operations to make it non-zero, so this will take again 3 operations to make it non-zero. So the total would be 4 plus 2, which is 6, 6 plus 3, 9. Is 9 less than or equal to 4? No, it's not, right? So this is also not a valid k. So next I will choose 3. Next I can choose 4, right? So I have to pick a smallest k value such that it holds this particular relation. Okay, so do I have to pick each and every relation? Let's say I have picked a big value k. Okay, let's have pick k equal to 99. Okay, so if k equal to some k dash was satisfied, then all the k values which are greater than this k dash will also satisfy. Okay, if k dash is valid, okay, when I say valid, it holds a condition of number of operations is less than or equal to k dash into k dash. Okay, so if a particular k value holds true, okay, then all the numbers which are greater than this k will also hold true. Okay, all the numbers which are greater than this k dash will also hold true. So what I mean is, if you see k equal to 3 holds true, okay, so if you see when I use k equal to 3, the total number of operations is basically 6. Okay, 6 is less than or equal to 3 square. Okay, if I choose k equal to 4, let's choose k equal to 4 and see total number of operations we get. Okay, total number of operations we will get is 3 divided by 4 plus 1, which is 1, plus 7 divided by 4 plus 1, which is 2, 5 divided by 4 plus 1, which is also 2, which is 5, right? Total number of operations is 5. 5 is less than or equal to 6, right? So I have chosen a k value which is greater than this minimum k value, and it will also hold true, right? So if a particular k value holds true, that means all the k values which are higher than this will also hold true. So there will be a point, okay, there will be a point till it will not hold true. Okay, so it will not, let's say x is not holding true, so k is basically increasing in this direction. Okay, So for k equal to 1 it will not hold true, k equal to 2 it will not hold true, k equal to 3 it will not hold true, and at k equal to 5 it will hold true. Okay, and from here onwards for all the numbers it will hold true. Okay, so I have to identify minimum k value such that it holds the given criteria, right? So can you see any pattern over here? K is actually increasing, right? K is actually increasing, k is strictly increasing, right? And there will be a point where from which it will actually holding. Okay, since k is increasing, can I use binary search on k? Yes, that is correct. So the idea is to use binary search on k and check whether this condition holds true or not. So what is the possible range for k? The possible range for k would be from 1 till all the way up to the summation of all these elements. If I go in the range of 1 till if I choose left equal to 1 and right equal to summation of all these elements, that range would be sufficient for me. I don't have to check for higher numbers. Okay, so that is what I've done. I've defined a variable called long sum equal to 0, and then I'm identifying sum of all the elements, and then I have defined my range for my binary search. Left is equal to 1 and right is equal to sum. Now my aim is to find the minimum value, right? So let's say I've chosen mid is this. Okay, if binary while left is less than mid, okay, I'm just identifying mid. I have written a function good which will tell me for a given mid value, that means for a given k, whether this condition holds true or not. Okay, if this condition holds true for a particular k value, that means this is my potential answer, right? So I am defined my right equal to mid. Okay, if it does not hold true, okay, let's say mid is this, if it does not hold true, that means this is not my potential answer, so I have to search in the remaining space. Okay, so my left would be mid plus 1. Okay, so whenever this loop ends, that means left and right will be equal, so my answer would be one of those. Either I can return left or I can return right. Okay, so how does the good function look like? Good function is basically the calculation which I mentioned, right? So you have to divide each number by k and take the ceiling value of it. So this is what mathematically I have done. You can also use inbuilt functions also. So this will give me integer part, and if the remainder is the remainder is greater than 0, then I have to add 1 to it. If it is exactly equal to 0, then nothing to add it. Okay, so in the end, if the total number of operations is less than k square, that means it is a valid k. Okay, so let's try to submit this. As you can see, it has satisfied all the test cases and it is pretty efficient solution. Okay, so I've noticed, like I have participated in like few of the contests, and I have noticed that in most of the contests at least one problem will be an implementation of binary search. Okay, it will be in the similar kind of variation. Okay, where you have to apply binary search on the answer value. Okay, here we have to identify k, now we have to apply a binary search on k. Okay, so I've seen this kind of pattern where they are asking this question, and it is pretty important concept, so make sure you understand this concept properly. Okay, so yeah, that's all about this problem. If you like the explanation, hit the like button and share your valuable feedback in the comment section, and don't miss to subscribe to my coding channel for more such coding videos. Thank you.